My name is Abasibianke James, and I and my teammate will be presenting on the data warehouse platform, which is Amazon Redshift. So first of all, we will be going through what Amazon Redshift entails, what it's all about, the different components, architecture, and so much more. And further down, we would give a live demo on Amazon Redshift. Okay, let's dive in. Okay, so what is Amazon Redshift? Amazon Redshift is a data warehouse service that operates in the cloud. Now it's fully managed, and it has great scalability. What do I mean by that? The data that it contains, it's able to hold so much data ranging from a gigabyte of data up to a petabyte of data. And from this data, you can then perform data analysis queries, and from these queries, from the analysis, you can then gain insight about your data. As a business owner or as a customer, you can gain insight and be able to make better business decisions. Also, on the side, we can also see this image which talks about the features of Amazon Redshift, and it says Amazon Redshift is fast, it has fast query performance, it's compatible with other tools, it's simple to use, it has great scalability of data, it's fully managed, it's secure, it's cost effective. And for each and every of this feature, we will look at it further down in this presentation. Next, we will look at the feature of the architecture of Amazon Redshift. So Amazon Redshift works in cluster, and we can see the cluster in this dotted line in this image. So the cluster is comprised of the leader node and the compute node. It also interacts with client application. Now, what do I mean by client application here? Client application has to do with other tools that are integrated with Amazon Redshift, and these tools can are integrated to be able to perform ETL or ETL operations, and also like BI reporting, data mining, and so much more other performance. So they are integrated with Amazon Redshift. And yeah, so we would be looking at how they relate with the leader node and the compute node. Also, we have other components of Amazon Redshift listed here down below, and we will be discussing each and every of these features further down in this presentation. So we have the leader node. As we said before, we have the client application. Now, this leader node is the, should I say, middleman between the client application and the node and the compute node. So it manages all the communications between these two components. So it also performs query execution, and when the execution process begins, it compiles all the code. All the compilation of code is done in this leader node. Now, the code that is being compiled is then sent to the compute node, and the compute node is where the actual execution of query is. And data, when it's compiled and run and everything, it sends this result back to the leader node, and then the leader node can further process it and report back to the clients, etc. We also have the node slice. Node slice is subcomponent of the compute node. So the compute node is divided into slices. Each slice has a memory, it has a storage, a disk space, and everything. We also have this feature or component in Amazon Redshift, which is massively parallel processing. This is the feature or the component that enables or gives Amazon Redshift the fast performance, for querying data, and so much more. So it enables fast processing of complex queries and huge amount of data sets. Okay, moving on to the next, we also have this internal network. This component just talks about how it manages all the connectivity and network communication between all the different components of Amazon Redshift. We also have database, which is a component or a feature of Amazon Redshift. Now, Amazon Redshift is a relational database, and also it's compatible with other relational database applications and can be integrated with them. Now, moving forward to terminologies in Redshift, we have different terminologies in Redshift, which are very common in Amazon, in AWS, but the terminologies that are very specific to Redshift can be found, when querying. And we have different terminologies like bounding box, geometric simplicity, geometric validity. Now, bounding box has to do with, talks about how Amazon Redshift processes geometric predicate and partial joinings very fast. And it does this by computing or pre-computing and storing boundary box in the geometry. We also have geometric validity, where geometric algorithms and conditions are applied to an input geometry to see if it is, a valid geometry or not. The same thing applies to a geometric simplicity. Several applications or algorithms, or conditions are applied to this input geometry, and then it is, checked to see if it's simple or if it's a complex geometry. Moving forward, we also have cloud capability. From this image, you can see the different cloud capabilities of Amazon Redshift. On the cloud, it's very fast. It offers very fast performance. It's easy to set up, to deploy, to manage. It's cost effective. Its scalability is great. It can perform so much. It can perform so many data analysis queries, and it's very secure. And here we can also see how things operate, in Amazon Redshift on the cloud. So the data, whether it's a transactional data or whatever data, it's passed into or it's loaded into the Amazon Redshift. Amazon Redshift is serverless. It's similar to SQL. This whole features talk about Amazon Redshift. And once this data is loaded into Amazon Redshift processes it, carries out different queries on it, and can then give insights about the data. So you can analyze, visualize your data, give real-time and predictive analysis about this data, and so much more. And this would help the business owner or the customer make better decisions. Now, this is a very important capability or point about Amazon Redshift. ETL and ELT and ETL. This is extract load transform and extract transform load. In Amazon Redshift, extraction and transformation of data cannot entirely be done on Amazon Redshift. So Amazon Redshift can only load data, but it has to be integrated with other tools like Glue or so many other tools to be able to perform the extraction and the transformation of this data, which is then loaded into the Redshift application to be able to perform different queries or different data analysis queries on them. Moving forward, Amazon Redshift also performs or offers great data security. So it does this using either e-data or infrastructure. And the e-data has to do with, certain features or certain security feature that Amazon Redshift offers is data encryption and tokenization, where it sends you a token before the data is being accessed, and your data is also being encrypted so that anyone who doesn't have access to your data or who is not authorized to see your data won't be able to understand what your data entails because it's encrypted. We also have infrastructure as well, which also protects or makes the data more secure. We also have a list of competitors of Amazon Redshift, which have some features that seem advantageous over Redshift. So some of the top competitors are Snowflakes, Google Cloud, BigQuery, VTK, Azure Synopsys Analytics, SQL Server 2019, IBM, Cloudera, Teradata Vintage, Databricks Lakehouse Platform, Panoply, etc. Moving on to the pricing, as we said earlier, Redshift is very cost effective. And what do I mean by that? Redshift offers a range of pricing. So as a user of Redshift, anyone who is using Redshift has a list of pricing he or she can choose from. And from this, list, we can see the different pricing that someone could, choose from. And also, another thing about Redshift is that they offer this free trial where you can, use several features of the Amazon Redshift for free if you qualify for it. And if you want to learn more about Amazon pricing, you can also click this link. And if you want to calculate the pricing for a service, you can also click this link. So in conclusion, although Amazon Redshift is very good, it has, great scalability, it has high performance, it can perform queries very fast, very accurately. It has great security and, great, it can handle so much data and so much more. It does have great advantages. But when you are working with, when you want to perform operations like ETL or ELT, you have to interact with other data to be able to perform these operations. But that is basically all for Amazon Redshift. Next, we'll be going on to the demonstration of this Amazon Redshift.
My name is Juan Pablo. I am in the group number 13. I am working with Abbas. And about the project, we use Redshift. In this moment, I will go to the Redshift. Okay. I will go to the Redshift. That is my own, what is the name? My own account, okay? First, for start to create a Redshift, we need to create a VPC, okay? Go to VPC, select VPC, and have to create 3 subnets. These 3 subnets have to be in 3 different zones. For example, in this subnet, that is in Zone A, US Zone A, Zone B, and Zone C. Okay. After we create a zone, go to the Redshift and start. Okay. Create workspace. Demo Abbas and Juan Redshift version 3. Okay. Select VPC. VPC is the end of the 7BE. Okay. Select a security group, a subnet, the 3 subnets, and what more. And that's all. Create a namespace. Here, namespace is 13. Okay. Database depth, permissions, associate Amazon Redshift, a custom encryption. We will create a Redshift in KMS, and that's all. Create. That is creating. Okay. That is the form we need to create a Redshift. When we go to the before, because we have a 2 version, we go to the version number 2, we can go to query editor. I can create a table. When someone can create a table, it's similar to ESQL. For example, create table demo2 ID integer and name string. That's all. Play start. We can go to the create connection first. Okay. Not a second. Here we have the dev public. In the first version, we have a table 1. I can demo 2 run. Run. Maybe it's varchar 20. Okay. If I go to here to the table, we have two tables. Okay. When I try to insert into demo 2 values, I can insert values. Okay. Number 1, execute. Values insert into demo 2 values 1. Maybe if I go to if I want to see, I only need to put select from demo 2. Nice. That's all of my part.